Okay, today's video, section 1.3, is going to review the distance formula and the Pythagorean theorem. Our example, to find the length of the segment JK, given the point J is negative 2, 4, and K is 1, 3. I already took the time to place the points in a coordinate grid. We have our x-axis, we have our y-axis, and each point. JK is the segment. We would like to find the length of that segment. To find the length of a segment, we're going to use the distance formula. The distance formula measures the length between 2 points. The distance formula, as you might remember from Algebra 1, is the square root of x2 minus x1 quantity squared plus y2 minus y1 quantity squared. So it's the difference of the x's squared and the difference of the y's squared. First thing we're going to do is we have to label our x and y points. I always label the first pair as x1, y1, x2, y2. Once we know what our x1 and y1 and x2, y2 are, we're going to substitute them into the distance formula. So to start, I always draw the big square root sign, and then I substitute in. The first thing I'm going to substitute in is my x values. So x2 we labeled as 1. x1 we labeled as negative 2. y2 is 3. y1 is 4. I substitute those in. Notice everything in red is the substitution of the points that we labeled above. The next thing we're going to do is we're going to simplify what's inside the parentheses. The first thing we're going to do, if you look, we're going to have to chop. We have a subtraction of a negative. So once we chop, right up here, this becomes 1 plus 2, which is 3. And if you look at the other parentheses, 3 minus 4 is negative 1. Notice how everything else stayed exactly the same. We still have the square root. We have not used the squared values yet. The next thing we're going to do is we're going to actually square. 3 squared turns into 9. Negative 1 squared. Remember, negative 1 times negative 1 is a positive 1. We still have the big square root symbol. The next thing we have to do is we're going to add 9 plus 1 to get 10. And then we're going to use our calculator for right now. And we're going to round to the nearest tenth. In this case, we have 3.2 units, and our segment JK has a distance of 3.2 units. The second method we're going to look at today is going to be involving the Pythagorean theorem. The Pythagorean theorem, if you remember, is c squared equals a squared plus b squared. Now there is a reason why we have c squared written first. You may have learned it as a squared plus b squared equals c squared. This will come up later on in geometry. To start, we have to use the Pythagorean theorem for right triangles. So what I need to do is I need to create a right triangle right here on our coordinate grid. And I'm going to look and label my A, B, and C. If you remember, A is one of the legs of the right triangle, B is the other leg, and C is the hypotenuse, the longest side across from the right triangle. First thing we need to do is we need to figure out the length of each segment. This length here, going straight up down, is 1. The horizontal section has a length of 3. And in C, we don't know. So the next thing we're going to do is we're going to take Pythagorean theorem, and we're actually going to substitute in the values we know. We know that A is equal to 1. We know that B is equal to 3. And then we're going to evaluate. We know that if I take 1 and square it, I get 1. 1 times 1 is 1. 3 squared, 3 times 3 is 9. We're going to add the 1 plus the 9 to get 10. And then we have to get rid of the squared value. To get rid of a squared, we're going to use the square root. We have to do that to both sides. The square root of c squared is just c. And then we have the square root of 10. Well, we saw over here already the square root of 10 was equal to 3.2, which means the length of our segment, or hypotenuse of the right triangle we created, which happens to be segment JK, is 3.2 units long.